All right, so we're on page 140. They want us to prep for solving equations by factoring. So, hold on, yeah. People in the waiting room, let's see. Okay. So right here, they just want us to factor. We're preparing for solving, if this was an equation, solve for x. But these problems, we're not solving yet. We're just going to factor these to make it easier to solve. So if we're going to factor this guy, we look at the coefficients first. We see we can at least pull a 2 out, right? If we factored out a 2, we would have a 16x cubed minus x. Now if we look at the x's, we see we have an x in both of them, so we know we can pull at least one x out. That would give us a 16x squared minus 1, right? X times 1 gives us our x, and this x times the x squared gives us our x cubed. Now if we look at this guy, we can factor this as well. Notice this is the difference of two squares. Remember, I told y'all if you have the difference of two squares, this is a plus b times an a minus b, right? So you have the a times an a is your a squared. Your b times your b is your b squared. And you have a positive ab and a negative ab, and those cancel out. Those cross terms cancel. So difference of two squares. If you notice in here, the 16x squared, that's 4x squared, right? And 1 is the same as 1 squared. So we can factor this guy as a 4x minus 1 and 4x plus 1. See, that gives us our 16x squared. This gives us our minus 1. Then we have this a positive 4x and a negative 4x. So the x terms cancel one another out. See, there are no x terms. We just have the x squared and the 1. So this would be our full factorization. If this were an equation, if this was equal to 0, and we were solving for x, say this was equal to 0, what we would do is we take each of these three terms and set them equal to 0. You can see here that if you plugged a 0 in for x, this would be 0, right? And 0 times anything is 0. So if we were solving, we would set each one of these terms equal to 0 and solve. So this thing has a x to the third power. So there would be 3 solutions to this equation. One of them would be x equals 0. You can see if you plug a 0 in for x, you'd get 0, right? The other one would be if this term was 0. Right? 0 times, doesn't matter what these two terms are, it would be 0. So we would have 4x equal to 1, or x equal to 1/4. So if you plug a 1/4 in to this equation, right? If you had a 1/4 right here, you'd have a 1 minus 1 is 0. So that would be equal to 0. And then this one right here would tell us that x is negative 1/4. So that would be a solution, this would be a solution, and this would be a solution. If we were solving this equation. All right. Again, we didn't have to do that. All they asked us to do was factor this to prepare it for solving. So this would be the factorization to prepare it for solving if it were an equation. All right. So let's look at the next one here. All right. Again, we look at the coefficients, and we see we can at least pull a 25 out, right? So we got an x squared plus 4. All right. Now, looking at this, that doesn't, well, x is squared and the 4 is a 2 squared, right? But this isn't a difference. But we can treat it as a difference. Remember, I squared is -1, right? Because I is the square root of -1, right? So if you square both sides, the square root of -1 squared would be a -1, okay? So keeping that in mind, we can write this as a difference, all right? This is an x squared minus 2i squared. All right, the 2 squared gives us a 4, and the I squared gives us a minus, and the minus and another minus give us a positive. So even though it explicitly says plus here, we can rewrite it as with the negative as a difference of 2 squares. So we could factor this as an x minus 2i and x plus 2i. I know a lot of y'all will see this and you'll just leave out the I. The I is important, all right? Without the I, you're getting the wrong answers, you see? See, check it out. X times x is x squared. We got a plus 2ix, a minus 2ix, and then this last one, we have a negative 2 times 2 is 4, and the I times I is I squared. Right, these go away, and this I squared is a -1. The minus and the minus give us our plus. All right, so that's a trick that you can use, but you have to make sure that you get the I involved when you need to, okay? Again, this doesn't look like the difference of 2 squares, but it is when you include I to give you that extra -1. Okay? $34 here. This one's straight up difference of 2 squares. This is 7 squared minus x squared. So we could write this as 7 minus x, 7 plus x. Okay, kitty cat. Say hello to the class. Quit tinkering with everything on my desk. All right. Okay. All right, so you could check your work. You have the 7 times the 7 gives us your 49. The positive 7x and the negative 7x cancel each other out. And then you have a minus x squared. All right, this one, there are no coefficients, but we have powers of x. We see the highest power is cubed, the lowest is x to the first, so we can factor out a single x here. We get an x squared minus 1, all right, x cubed minus x. We can factor this guy. It's got the squared in it. Remember, 1 is the same as 1 squared. This is the difference of two squares. This is an x minus 1 times an x plus 1. All right? Our x squared, there's our minus 1. And we got a positive x and a minus x. So those cancel out. And you're left with simply the x squared and the 1 squared. So this would be our factorization. All right, let's look at 36 here. We look at our coefficients, the 3 and the 12. We see we can factor out a 3 at least. All right, 3 times 4 is 12. Now looking in here, there's x's in both the terms, right? So I can pull out at least one x, and I would be left with x squared minus 4. And this is the difference of two squares. 4 is 2 squared. So this would be an x minus 2 times an x plus 2. All right, now we have this thing fully factored. Any questions?
No, sir.
No, sir.
All right, let's see. We are now on page 141. So let's check out our homework on page 141. Let's see, using the square root method. Let's do a couple of quiz problems from page 135. There we go. So, you can take, say, 10 minutes to do these. It shouldn't be too hard. Come back at 9:27. I'll put you in your breakout rooms. Be sure to help one another out.
Yes, sir. you go over them, please?
Yes, absolutely. So we'll give it another 30 seconds for breakout rooms to finish closing. Okay, class. Let's check these problems out. Move this one down a little. So this guy here, let's see. If we add 23/5 to both sides, we get 1/10 x squared equals 23/5. Now if we multiply both sides by 10, we got x squared equals 230 over 5. So we can reduce this. Let's see, 230 divided by 5. 230 divided by 5 is 46. Okay. So if we square root both sides, okay, we end up with that. The square root of x squared is the absolute value of x. Okay. And let's see what we can do here. 46 is 2 times 23, right? So we can't simplify or pull anything out of this the square root. So all we have here is x is positive negative square root of 46. Okay. Now for number 2. See if we add 1/4 to both sides. We got 1/3 x squared is 115 over 12 minus 1/4. And we can combine these. If we multiply this by a 3 over 3, so we have a 12 on the bottom. This leaves us with 3 times 1 is 3. So 115 minus 3 would be 112 twelfths. So let's see if we got 1/3 x squared. We can reduce this, right? If we divide the top and the bottom by 2, this would be a 56 over 6. We can reduce some more. This would be a 28 over 3. So we have that, right? A little there for us. All right, so here, if we multiply both sides by 3, our x squared is 28. So square rooting both sides. See, 28 is what? 2 times 14. Which is 2 times 2 times 7. We got two 2's here, right? That's 4. The square root of 4 would be 2.
Sir, did you already click the questions with for the quiz?
I'm doing them right now. This is number 2.
Oh, okay. Can I take a picture of it real quick for the first question?
Yeah, go ahead.
Okay, thank you.
And here's the second one. So we have the square root of x squared equals 2 root 7. So that tells us the absolute value of x is 2 root 7. That tells us that x is positive negative 2 times the square root of 7. All right, any questions about these?
No, sir.
No, sir.
All right. So I think we're on page 141 or something. Yeah. So let's see what they have to say here. Solving equations by factoring. So the graph down here is the graph of x squared plus 3x minus 10. Okay. Notice that the x-intercepts occur at a negative 5, 0 and at 2, 0. We can use the x-intercepts to write the factored form of this quadratic function by moving the x-intercept over to the other side. So you're saying these are our solutions, right? Our intercepts are at x equals minus 5 and x equals 2. So if you take x equals minus 5 and add 5 to both sides, you get x plus 5 equals 0 and x minus 2 equals 0. So what they're saying here is that this guy's solutions are at minus 5 and 2. Well, it's x-intercepts. Okay, so the factorization is going to be an x minus negative 5 and an x minus 2. All right, if you plug a 2 in, 2 minus 2 is 0. All right, remember when you find the x-intercepts, you're setting f of x equal to 0 and solving for x. So if you plug a minus 5 in for x, you'd have minus 5 plus 5, right? So you have, right, that's our factorization. This is our function, x squared plus 3x minus 10. These are the same thing. And we know that's the factorization because if we take this and we graph it, we look at the x-intercepts, all right, they're at minus 5 and 2. So our factors are x minus a negative 5 and x minus 2. Okay. So here's another example. All right. Here's our x-intercepts, 0, 0, and 4, 0. So we have x equals 0 and x equals 4. So our factorization is going to be an x minus 0 and an x minus 4, right? Which is x times an x minus 4. If you look at the function, You can see, factor out an x, you have an x minus 4. So you can just look at the x-intercepts and write down the factorization for the function. All right? Just by looking at the x-intercepts, you can write down what the function actually is in its factored form. See, it's x squared minus 4x. We didn't even know that. All we did was look at the x-intercepts. These 2 points alone tell us exactly what the function is. Okay. See, this is a quadratic. It looks like that or like that. If you have like a function that's like an x cubed, it would go like that, and it would have 3 intercepts. But the same thing would work. You just take an x minus each intercept and multiply them together. So this works for more than just quadratics. It works for higher powered functions as well. Sketch a possible graph for the quadratic function given in factored form. You can see right here that x equals 5 would be a intercept, right? Because if you plug a 5 in here, you're going to get 0. That's where the function is equal to 0. Or a negative 2. If you plug a negative at 2 here, you get 0. So that's also where the function is 0. So here at negative 2 and 1, 2, 3, 4, 5. All right. This thing either looks like that. All right. We know it's not like that because x times x is a x squared. It's positive. All right. If the x squared was negative, then it would be upside down, remember? So that's a possible graph. You know, as long as it goes through these 2 points there, that's it. Okay. Yeah, it might be this, you know, but this is a possible graph. You know, it could be any possibility of quadratic that goes through those 2 points, but that's one possible graph for this. All right, this one, if you plug a negative 6 in, you're going to get 0. So negative 6 is where the function is 0. And a positive 6, if I put a positive 6 in there, this is 0. So the whole function would be 0. So over here at negative 1, 2, 3, 4, 5, 6, and positive 1, 2, 3, 4, 5, 6. All right, these are 2 of the x-intercepts. The x times an x is a positive x squared, so we know that this thing opens upward. All right, so that's a possible graph for this quadratic function. All right, let's look at this one. So let's see, we're looking at the graph of 6x squared minus x minus 12. That's what this graph here is. The x-intercepts occur at negative 4/3, 0, right? And 3/2, 0. So we have x equals 3/2 and x equals negative 4/3, right? Our intercepts. So our factors here would be x minus 3/2 and an x minus a negative 4/3. So that'd be a plus 4/3. All right, this is equal to that. To make this pretty though, if we rewrote this one as see 2, no, not 2, pull out a half. This would be a 2x minus 3, this guy here. See, the 1/2 times the 2 give us just x, and the 1/2 times the 3 gives us the 3/2. We pull that out just to make our factor pretty without fractions in it. This one we do the same trick. We'd pull out a third. So this would be a 3x plus 4. And then we put these two things together to make a 1/6. 2x minus 3 and a 3x plus 4. That way these are pretty and don't have fractions in them. Okay? That's just, I mean, these are all equal. See the equal signs? They're all equal to one another, you know? But the two forms that we like the best are either that one in its unfactored state, or this one where it's factored and we've pulled all the fractions out of the factors, just because it's prettier, all right? Okay. You can see up here that they just start off with each x-intercept, and they end up with the same factors, you know, with their approach. So they call this using the zero factor property, is what this is called. So if we look at this one, all right, they want us to solve this using the zero factor property. All right, so we factor it. If any of the factors are 0, then that gives us a solution here. So let's see, this, all right, is the difference of two squares. This is 3x squared minus 4 squared, right? So we can factor this as such. We have a 3x minus 4, 3x plus 4. So this time we actually have equations. We're not just given something to factor. All right, we're given a whole equation and we're factoring in order to solve it. See, that gives us our 9x squared. That gives us our negative 16. And then we got a positive 12x, negative 12x. So the x terms go away. So there are no x terms in here. So now, if either one of these factors is 0, the whole thing is 0. So either 3x minus 4 is 0, or 3x plus 4 is 0. So this one tells us 3x is 4, or x is 4/3. And this one tells us 3x is negative 4, or x is negative 4/3. So these are our two solutions to this equation. Okay. Any questions?
No, sir.
No.
All right, let's look at this one. So first thing we want to do is set this thing equal to 0, right? We need it equal to 0 before we factor it. All right, otherwise the 0 factor doesn't work. So if we subtract 9 from both sides, we get this guy, right? Yeah. So now we need to factor this thing, right? So it's not the difference of two squares. can't use that trick, you know. So this one we can just eyeball, right? We know we need an x and an x to give us our x squared. To figure out what numbers to put here, we need two numbers that multiply to give us 7 and add to give us 8. So luckily a 7 and a 1 work out, right? That gives us our 7. We'll get a 7x and a 1x, add to give us our 8x. Okay, so solving this, you can see if I plug a -7 in here, right, I get -7 plus 7 is 0. 0 would be 0 times a -6, but 0 times anything is 0. So we could see that either x has to be a -7 or x has to be a -1. All right, we can write it this way. X plus 7 has to be 0 or x plus 1 has to be 0. Either one of these factors has to be 0. This would tell us x is -7. This would tell us x is a -1. So these are the two solutions to this equation. All right, if I plugged a -7 in here and here and added 16, I would end up with 9. Okay. All right. Again, this one we need to move everything to one side, set it equal to 0. So if I add 7x to both sides and I subtract 2 from both sides, I would have that. Now this thing's in a nice standard form. So let's see, this guy, in order to factor it, remember our trick here? Our a times our c, a is 2, c is 3, right? Is 6, right? So we need two numbers, a p and a q, so that when we multiply them, we get 6. Our b here is 7. So we need our p and our q to add to give us 7. See, we're going to rewrite 7x as like something x plus something x, right? So that we can do our grouping trick. So let's see. Two numbers that multiply to give us 6 and add to give us 7 would be 6 and 1. So let's rewrite 7x here as a 6x plus x. All right, so this one, these two, we can pull out a 2x. That gives us an x plus 3, right? And then we have an x plus 3. See how we have x plus 3 and an x plus 3? All right, how do we factor this out? Well, we can write this as a 1 times x plus 3. So what you see here is we have a 2x and a 1, and both of them are multiplied by x plus 3. All right, so either 2x plus 1 is 0 or x plus 3 is 0. So this one tells us 2x is minus 1 or x is a -1/2. This one tells us x is a minus 3. So those are our two solutions to this equation. I know a lot of y'all are going to get hung up on this step here, all right? Because you got the x plus 3 here just floating, right? Just to remember to write that as a 1 times an x plus 3 so that you can have the same factor written twice and be able to factor it out, okay? All right, let's put this guy in standard form. We got an x squared over 9. We'll subtract 2x over 3 from both sides. All right. So all these fractions here, we don't need them. Let's just multiply both sides of this equation by 9 so that it gets rid of all these fractions. See, we get an x squared. 9 over 3 would be 3, and times a 2 would be 6x. See how this is a lot easier to work with than this, simply by multiplying both sides by 9. We can do that because this side is just 0, and anything times 0 is 0. Okay? Y'all follow that trick? This is a lot easier to factor. So we can factor this just by eyeballing it, right? X and an x give us our x squared. Two numbers that multiply to give us 9 and add to give us a -6. We'd have to have a -3. -3 times a -3 is a +9. We have a -3x and a -3x give us our -6x. So here, either x minus 3 is 0 or x minus 3 is 0, right? They're the same thing. So x equals 3 or x equals 3. So what we see here is this equation has one solution, x equals 3, but it has what we call a multiplicity of 2. It's the same solution twice. All right. So what this guy would look like if we graphed it would be over here at 3. That's where it just touches it. Okay, so there's one x-intercept at x equals 3. All right, but it's just touching it. All right. Okay, this guy here, look at all these x's in here, right? We can definitely pull an x out. First, let's rewrite it in highest order to lowest order. We got a 4x cubed and a 20x squared and a 25x. So I just rewrote it so the highest power of x is first. If we look at the coefficients, they're all a little different. We can't pull a 2 out of any of them. We can't pull a 4 out. We can't do anything with the coefficients, but we can pull an x out. It gives us this. So this guy, we need to be able to factor it, okay? So since it has that 4 up front, let's use our AC or our trick here. Remember, our A times C, 4 times 25 is 100. So we need two numbers, I'll call them P and Q, that multiply to give us 100. Our B here is 20. So we need our P plus Q to be 20. Right? Our goal is to rewrite this 20x as a sum. So two numbers that multiply to give us 100 and add to give us 20 would be 10, right? 10 times 10 is 100, and 10 plus 10 is 20. So if we rewrite this 20x as 10x plus 10x, all right, use my square bracket here. So we're going to have brackets inside of brackets. Looking at this, if I pull out a 2x, I have a 2x plus 5, right? That's the 10x. That's the 4x squared. Now over here, if I pull out a 5, I have a 2x plus 5 as well. So notice I'm using square brackets, right? Because we have all this stuff in here which has brackets, but there's a plus, you know? It's not all multiplied together. We have an addition in here. So we have a 2x and a 5. Actually, I don't need that anymore. A 2x and a 5, and they're both being multiplied by a 2x plus 5. Oops. So that is our factorization. So here we have 3 factors, 1, 2, 3. So either x is 0, or 2x plus 5 is 0, or 2x plus 5 is 0. Okay? So that's one solution. These are both the same, right? So we have 2x is a minus 5, or x equals negative 5 halves. Okay? So these are our 2 solutions. This one has a multiplicity of 2. The same factor showed up twice. All right, this one, let's see, we could pull a 2 out of everything, right? T squared plus 9t plus 18. Now we can just divide both sides by 2. And we're left with just this guy. All right, 0 over 2 is still just 0. This, I think we can just look at it. We need a t and a t to give us our t squared. 2 numbers that multiply to give us 18, that add to give us 9. 6 and 3, right? They multiply and give us our 18. The 6t plus the 3t gives us our 9t. So either t plus 6 is 0, or t plus 3 is 0. This one tells us that t is negative 6. This one tells us that t is a negative 3. So these are our 2 solutions to this equation. Any questions?
No.
Excellent. All right, let's get this thing into a standard form. Just subtract 5x from both sides, right? Here we can pull a 5x out, right? That would give us a 2x minus 1. Right, 10x squared minus 5x. So either 5x is 0, or 2x minus 1 is 0. So this one tells us x is 0. This one tells us that x is 1/2. We add 1 to both sides and divide by 2. So these are our 2 solutions to this equation. All right, look at this ugly guy with all these fractions. I bet we can get rid of these fractions. First, let's put it into a standard form, subtracting 3/10 from both sides. Now, to get rid of all these fractions, let's just multiply both sides by a 10. All right. If we do that, 10 over 5 is 2. Let's see, 10 over 4 is 10 over 4 would be 5 halves x, right? And then the 10 over 10 would just be 1. And 10 times 0 is 0. So look at that. We got rid of almost all the fractions, right? We still got a 2 down here, right? Let's just multiply both sides by 2. So I got a 2 times 2 is a 4x squared. 2 and the over 2 go away. It gives me a 5x. And the 2 times a negative 3 gives me a negative 6. And again, 2 times 0 is 0. So I'd rather deal with this than that, right? So I just multiplied both sides by numbers until I made all the fractions go away. Now in order to factor this, since we got this 4 in front of our x squared, it makes it hard just to eyeball. We'll do our little trick here. We'll look at a times c. 4 times negative 6 is a negative 24. So we need two numbers. So if we multiply them, we get negative 24. Our b here is 5. So we want our two numbers to add to be 5. So if we look at this, let's see, possibilities for p times q would be maybe 24 and 1, but those don't add to be 5. We can look at 12 and 2, all right, a positive 12 and negative 2, that would give us a 10. So let's see.
8 and negative 3.
What was that?
8 and negative 3.
There you go. If p is 8 and q is negative 3, right? They multiply to give us a negative 24, and they add to give us a positive 5. So let's rewrite this 5x as an 8x minus 3x. So looking at these first two terms, if I pull out a 2x, I get a 2x plus 4. And then looking at these second two terms, if I pull out minus 3, I got an x plus 2. So that didn't work. I didn't get the same two terms. So what I think I need to do is maybe rearrange these. See, if I do that, let's see, if I pull out an x out of these first two, I get a 4x minus 3. And then if I pull a 2 out of these second two, no, it's not working. Did I do something wrong here? All right, a 6 times 4 is negative 24, right? Yeah. B here is 5. So if I 8 minus 3 is 5. So I'm rewriting the 5x as an 8x minus 3x. This one I pull out the x. So I get a 4x squared minus 3x.
Something seems wrong.
What's that?
You said something was wrong, but I don't see anything that's wrong.
Well, if I factor out the 2 here, oh yeah, you're right. I get a 4x minus 3. Yeah, thank you. So yeah, we get the same term, right? So switching these two worked, right? When I had the 8x first, it wasn't working out. So I have an x and a 2, both multiplied by a 4x minus 3. So that tells us either x plus 2 is 0 or 4x minus 3 is 0. So x is a minus 2 or x is a positive 3/4. Those are our two solutions. So that's number 8. So it's about the end of class here. Let's look at exam. This is what, 17, right?
Yeah.
And see, where was our homework at? I forget what page.
135.
35. All right. So let's do some more of this solving using the square root method. Let's see. I know I haven't given all of these to you yet, have I?
That I know of, no.
Let's see, we did this one, right? Is that the one we did?
Yeah, we did that for the
Yes, we did.
quiz. We
Okay.
did 6 and 7.
6 and 7. All right. Did y'all do 4 and 5 yet?
No, I
I
don't
don't
think so.
remember. I don't think so.
I don't think so.
All right, let's do 4 and 5 then. All right. Make sure you watch out for the i's, right? The square root of a minus 1. All right. All right. Because these, if you subtract this 81 from both sides, you're going to get a negative 81. So looks like both of these you're going to end up with the square root of minus 1. So both of these problems you should have I in your solutions. All right. And they both have two solutions because they're x squared. Right. You're going to get that. So remember the absolute value of x. You're gonna get the plus and minus when you solve it. Okay. So get these in by midnight tonight, and I will see y'all on Wednesday.
Have a good day.
Thank you.
Have a good
Bye.
day, sir.
Thank you. Have a good one.
Yes, thank you. Have a good day.